this should go quick because this should be a review, right? So we're going to review what you learned yesterday. The x-intercept of a graph of a relation has a what coordinate of 0? Good. So it's where, whoa, try that again. Where y equals to 0. The x-intercept is where y equals 0. The y-intercept is where x equals 0. Okay, some keywords. Make sure you know for your quiz tomorrow what a relation is. Okay, what is a relation? What? How? Okay, so you said x and a y. So specifically, how many things do you need? 2 things. So you can think of it as, there's multiple ways you can look at it, but relation or a relationship between 2 things. Okay, a relationship between 2 sets. Another way we can think of it is a set of ordered pairs, because ordered pairs have how many things? 2, an x and a y that you're relating together. Okay, a set of ordered pairs. And then you talked about domain. We kind of introduced it a little bit earlier, but yesterday you went in depth. The domain of a relation is the set of all possible values, which can be the input or the independent variable. Right? The range is our y or output, all the different possible values for the output. So, let's do one of these. What would be the domain for this set here?
1, 0, 3, 5.
Okay, so 1, 0, 3, 5, and -3. We should probably go numerically in order. So what's first? -3, then 0, 1, 3, thank you, and 5. Okay, range would be all the y values. So numerically in order, what's the smallest? 2. Now I see 2 2s. But you only write 1. Good. 2, then 5, 8, and 9. Okay, easy? So set of ordered pairs, domain and range is easy. What are the x values? What are the y values? Okay. Should we look at this one? What do you think? Sure. Okay, this first guy. When I state the domain, whoa, I can't speak. If it's discrete data, we can just state the x values. So what are the x values? Oh, yellow. Okay, so what are all the x values? What are the location of the x's? -5. Oh, yeah, it totally is. -4. -3, right? All these x values of the coordinates. So -4, -3, -2, -1, 0, 1, 2, 3, and 4. There's one more way you could write this. Okay? You can write it like this. You can write it's between -4 and 4, comma, x is an element of the, what type of numbers are those?
Real?
They're not, well, they are, but because it's not the ones in between, integers. It's an element of the integers. Okay, so that's the other way you could write it. I think it's just easier if it's discrete, always just list them. Okay, you could do this, but now it's getting a little bit more complicated. Range. Location of the y values. So where does it land? Where are these y values landing? Can you see that okay? Should I zoom in? 300%. How's that? Now you can see it. Oops. Okay, so maybe it's a little too big. So 0, 1, 2, 3, and 4. So again, you could also write it, it's between 0 and 4, element of the integers. Okay, but that's an option, but if you want to do that, it's totally fine. They're both valid, the same thing. Okay, with these discrete data, it is easier just to write it like that. Okay? Let's go to the next page. All right. What's the domain of this guy? So let's ask ourselves, how far left will this graph go? Think about this curve. How far left is it going to go? Is it going to keep going to the left? Yeah, it's going to keep going to the right. Yeah, so if it goes forever to the left and to the right, how do we write that? X is an element of the reals. XER. Range. I think it's actually an epsilon, not an E. Proper name for it. But anyways. Range. How far up will this graph go? Forever. How far down does it go? Up until -3. So from -3 and up. How do we write that? First of all, which variable? Y is greater than or equal to -3. Because it's going up, right? Up is greater than or equal to. It's going up from -3. So we're going to use greater than or equal to. So up is greater. Alrighty. Let's go to C. What would be my domain? So who's your X? If you have a list of 2 sets of data, how do you know which one's the X, or the input, or the independent? The first one. The first is always your X. The second, or independent, your input. And that's why the direction of the arrow is towards the Y. You put in your X, and out comes your output, your Y. So domain would be, Josh, what's the domain? You with us? No, can you get back with us? Okay. 1, 2, and 3. Range. 2 and 6. Okay, let's draw this one. A circle with center -2 and 3. So we're going to have to do some drawing. So the center's at -2, +3. And it has a radius of 3. So from the center, you have to go 3 up, 3 down, 3 left, 3 right. So where does 3 up land you? What point would this be here? -2 and what? 6, good. Where does 3 down, where would you land? -2 and 0. Okay, now 3 to the left. Where would you land? This is at -2. 1, 2, 3. So -5 and 3. Yeah, and then 3 to the right. 1, 2. You'd land at 1 and 3. So that would be your circle. Sort of. Sort of looks like, yeah. It's not very circular. Nope. Okay, domain. How far left does this graph go? -5. Okay, you see that? -5 from here to here. And how far right does it go? The x coordinate. the x. 1. So it goes between -5 and 1. So if it's between two numbers, we put x in the middle. Which way should our arrows face? Both to the left, to the left. Is there a song like that? Everything you own. To the box, to the left. Yep. Range. How far high up? And it's from 0 to 6, right? It's going from 0 to 6. The y coordinates. From 0 to 6 right here. So if it's between, put 0 on the left, 6 on the right. Y goes in the center. So y is greater than or equal to 0 because it's above, but it's below 6, so it's less than or equal to 6. Good. Maybe not so bad? I don't know. Takes practice, right? You're going to have to practice. Tej, where does that go every class? I shouldn't have to ask you. Let's go. Come on. Okay. We're going to try one of these. Let's do this one. Draw the graph of a relation which has a domain of XCR, a range of y is less than or equal to 2, and only has one x-intercept. So there's so many answers. I'd like you to try and draw this. Draw a domain of XCR. A range is y is less than or equal to 2. And only one x-intercept. Anyone think of how you could draw that? Right now? Yeah, there is homework from this one. No, you did the textbook stuff? Oh. Oh. So you did the lesson for page 426 was assigned yesterday? And then how about worksheets? So today that will be? There was a handout yesterday.
Yeah, she gave us to us, but she didn't give us the numbers for the, we didn't have the number for the worksheets to work on, so we just did this.
Okay, so then we'll switch it. Your assignment will be the worksheets today.
Thank you.
Because if this is already done.
Yeah.
Okay? Okay, so let's open up to lesson 6. And we're going to review your graphing calculator. This one's short. It's very short. We'll take a look after. Okay? All right, lesson 6. Grab your graphing calculators. So we're going to review. We're going to put in together domain and range with the concept of domain and range with the concept of graphing calculator, which is a good review because your quiz is tomorrow. Yay! Lisa purchases a new car. I think we've seen this. Yes, we have seen this one. We did do this question, but we're going to look at different aspects of it. Oh, yeah. That's not annoying at all. So, grab your graphing calculators, type in that equation. So, right here. So, we have the value of a car can be represented by the formula 20,000. Let's go to Y1. 20,000 minus 1,250. And we don't have a t. We're always going to use which variable? X. Well, we do, but your calculator needs the x. We use it when we store letters. But for graphing, it only does x and y.
Yeah, but like
Alpha t. So alpha, push the green button.
so you wouldn't push like X to
Yeah, you would push that one, x to theta. But you would just leave it as x. So there's different modes on your calculator. And so if you change its mode, it's going to change it to a t or a theta or an n. But we always stick in So which one is it? There's like yeah, there's different ones. We never change it. Okay. All right, so we need to change our windows. So let's go through the instructions here. It says you can use the zoom fit feature as a guide, or we can zoom out. So if you push graph, yours probably doesn't look like this. Zoom 6 is standard, right? Yours probably looks like this and nothing shows up. You got a line? Oh. Oh, go back to y equals. Is that in there? Is that typed in?
Yeah, it could be the windows though. Like we might have to.
Yes. So we're gonna play with the windows.
Zoom 6.
So everyone go to Zoom 6. Make sure we're all in the same window.
Oh yeah, no.
Okay.
Oh yeah, no.
Okay. So if we want to zoom out and play with the windows here, how do we zoom out on something?
Zoom.
Zoom. Now there's a few options. It says we could try Zoom Fit. Zoom Fit, so we can zoom out, is one option, which is number 3. We could also try Zoom Fit, which is 0. And so what that does is it tries to put the line, it tries to make the best windows for you. They're usually not very good. Yeah, it is weird because you won't see your y-axis.
Or no, you see
Oh,
Y.
you see y, you won't see your x-axis. So if we did try it, we can all try it together. You get something like this.
Is that the?
Oh yeah, it looks like that is down there. If we want, we can modify it for ourselves and play around with this. Okay, so if we go back to Windows, we can see what they did. So they said x min is from -10 to 10. Okay, so that's x min, x max, scale 1. So instead of doing our minimum of 25,000, or sorry, 7,500 for y, what can I change that to? So that I could see the axis. If I want to see the x-axis, I still need to go lower. 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 I need to go 0 or less than 0 as my minimum on y. If I want to see the origin, right? If I want to see the origin, I need to go to 0 or less than. Okay, now you might want to play around with your scale because right now it's trying to make 32,500 ticks. So you could play around with that. We can maybe make it every 1,000 or 100, maybe 100 or maybe 1,000. It's up to you. I'm going to do 1,000. Okay, now let's see what that looks like. Now can we see our x and our y axis? Yeah. Now, is it going far enough to the right if I wanted to know about the the x-intercept? No, we'd probably have to go a little bit farther to the right. So in Windows, which one would I have to change? X minimum or X maximum? The X max. If I want to go more to the right, I need to change X max. So what should we change that to? 20. Sure, let's try 20. Okay, so graph that. Does that look better? Okay, so there we go. Now we got a better picture of our graph. Now, it says graph this here. So what are we graphing? What is my independent variable here? If we're graphing, it says the value of the car in dollars and T is the age of the car in years. T or age in years. Time is always independent, okay? If you're comparing something with something, they write it in a way that's y compared to x, okay? Y comes first. The value is your y compared to the time. So B, or value of car in dollars. Now, when we have an application problem, you have to ask yourself, is it possible to have negative values here?
Yes.
Is it possible to think about value of the car and age in years? No, we cannot have negatives. You can't have negative time. I'm telling you now, we can't go backwards.
Oh, no.
Well, if you owe money, like that kind of idea, or no, it's either worth nothing or it's worth something. A car never owes you, like,
Oh, yeah.
right? So either it's worth something or it's worth nothing. So there is no negative values here. Now we found, it says state our windows, so let's write our windows that we used. Our windows were, for x, negative 10 to 20, scale of 1. So remember min, max, scale. What was our y min we used from our graphing calculator? Go to your windows. So ours was, wake up, hello.
0.
Thank you. Oh, you're working. Window. So 0 to 32,500, scale of 1,000. Okay. Now, is there more than one answer there? Yeah, of course there is. Okay. There's wiggle room. As long as you can really see the graph and see what you need to see to answer the questions that follow, there's so much wiggle room in that window setting. Okay, sketch the graph. So, okay, here's a problem. How do I find a value if I wanted to know the y-intercept of this graph? Okay, hello. What is with you today?
It's sad because you weren't here.
Clearly, it's mad at me. Okay, how do I find with my calculator? Yeah. You're thinking of x-intercepts when y is 0. So if we want the y-intercept when x is 0, trace, and what? 0, enter. So 20,000. So we got this by going trace, 0, enter. Because our x value was 0. So that was 20,000 there. Okay, 20,000. And then how do I get the x-intercept? Remember? Before we go second trace, which you're right, we do want to go second trace, we have to do something first. Okay, go to y equals. Y2 is going to be, so what's the y value at your x-intercept? What's your y value at an x-intercept? Y is what? 0. So we set y2 equal to 0. Good. Then we go second trace, 5 for intersect. And then we push enter how many times? 1, 2, 3. Enter, enter, enter. 16. Okay, so now, does it make sense to connect these dots? So, can value of the money, think about value of a car. Can it be decimal values? Yeah. Age in years. Can you have something for 2.5 years? Yes, so we are going to connect these 2 points. Okay, so we already did some stuff. We already found the t-intercept. What was the t-intercept? The t-intercept. 16. What does it represent? So when I ask you what it represents in the context of the question, you need to relate it to value and age in years. So at that point, x is 16, y is 0, right? So after $16, 16 years, what? 16 years, the car is worth? The car has no value, or is worth $0.
Did we do this one? Yes.
We did. Yep. But there's some parts that are going to be new.
Yeah,
And it is a good review.
yeah, it's just
It is the same, yeah. Okay, the v-intercept is 20,000. Okay, that was the point 0 and 20,000. So what did that represent? Do you remember? A brand new car. So a brand new car, or the brand new car, or after no time at all, before it leaves the lot, at 0 years. It's worth $20,000 because time is 0. Okay, use a trace feature. Find out what it's worth within 5 years. So what would I type in? So what would I type in if I want to know its value after 5 years? Yep. Because time is an x, right, is the x value, trace 5 enter gives you enter, so it'd be 13,750. Okay, and last it says use the intersect feature to figure out what the car will be worth when it's worth half of the purchase price. So half of the purchase price. How much is half the purchase price? Which is $10,000. So they give us 10,000. So what do I do with that? Is that a y value or an x value? A y value. So what do we do? Go to y equals. Go to y equals calculator. Said go to y equals. Hello. Wake up. There you go. Okay, then go to y2 and change this to 10,000. So y2 is 10,000. So y2, we're going to set as 10,000. Then what do? Second trace. Second trace. We want to see that screen. And we want 5, which is intercept. And we push enter how many times?
3.
1, 2, 3. Okay, so this would be 8 years is the answer. Okay, so here's the part that I really wanted to get to. All of that to review, to talk about what is the appropriate domain and range for this function. So, first of all, domain. Is it x? Is the variable x that we use for domain or something else? T. Okay, so instead of x, it was t. And range was what variable? V. Okay, so in the context of this question, because this is not a regular just y equals equation, right? There's context to it. What is the range or the domain for the time? Between what two values can you own this car? 0 to 16. It would be 0 to 16. The graph exists from 0 to 16 because you can't have negatives. Okay, how about for the value? It's either going to be the least amount it could be worth was how much? 0. The most it could be worth, its initial amount of 20,000. Let's try one more that's a little bit different, and we can maybe move a little quicker. Okay, I know it's moving, but this is a good review for tomorrow. Okay, height of a human cannonball, a cano. I didn't know it had a name. Apparently it does. Okay, grab your graphing calculators. Let's graph this equation. So let's clear what's in there. And we're going to graph 12 plus 6x, good, minus x squared. And we should all reset our windows because it's always safer to do that. Zoom. And 6. Okay, let's see if we can see anything. Hey, we can see part of it. We just need to go what direction? Up. Everything else is okay. I just need to go a little bit higher. So if I go to my windows, which one am I changing to go higher? Y max. So what do you want to make Y max to? Well, we don't have to that high.
30.
Is 20 high enough? I'm going to try 20. Yeah, and then change it. I'm going to try 20. I could be wrong. Oh, you're right. 25? Okay, 30. Let's do 30. Y max, because I only need to go higher. Yay. Okay, so let's state our windows. X was still, did we change our X? No, negative 10, 10, and 1. And Y was 0, negative 10 to 30, scale of 1. Right, where am I finding those? If I just push the window button, we're listing this in order. X, negative 10, 10, 1. Y, negative 10, 31. That's what we're listing. Okay. Okay, so let's think about this context of this question. Can we have a negative height or negative time? No. So our graph really only exists from the y-intercept, and then it goes up all the way to the x-intercept. Something like that. It's not the greatest sketch, but it'll do. Because it doesn't can't have negative. What's going to go on the horizontal? Is it going to be height or time? Time is always on the horizontal, T. And vertical would be height, H. Okay. So tell me, it says, what is the height of the cannon above the ground? So the beginning of this question, the person is where? Like if you're a human cannonball and you're getting shot out of a cannon, at time equals 0, where are you? In the cannon. Okay? So if you're asking me what is the height of the cannon above the ground, we're really looking for our h-intercept. Oops. H-intercept. Okay, so what is the h-intercept? How do I find the h-intercept or the y-intercept? When x is 0, so x is equal to 0, or in this case, time is equal to 0. So if I know my x value and I want my y, what do I push? Trace, 0, enter. So 12. 12 meters. You can even add that to our graph. 12. Okay, this is new. What is the maximum height the cano reaches? You haven't learned how to do this yet. I teach you how. Second, trace. Guess which one we want. Second trace. Number 4, we want the maximum. Okay, now be very careful. It says left bound. So second trace for max is what we wanted. Now, it says left bound. So what you have to do is go to the left of the maximum point. Are we right now to the left side of it? Yeah, so push enter. Now it says go to the right side of it. So we're going to use our cursor, hold it down, and scroll over until you're on the right side of the maximum. So now, somewhere over here, I'm on the right side, push enter. And then it says make a guess. So what it does is it's saying, okay, our maximum is between these 2 points. I'm finding the highest, because you can actually have multiple maximums. They're called local maximums on graphs like this. So do I want this? Well, your calculator doesn't know which one you want. And that's why it's forced to tell you, okay, between which 2 values, which one do you want? That's why it's making you do that. You don't have to make a guess. You can just push enter. If you want to scroll over and say, oh, my maximum's over here, you can, but you don't have to. You can just push enter. And what is it? 21 meters. At what time? After how long? 3 seconds. Yeah, it's kind of rounding it. So it's 3 and 21. So the maximum height would be 21 meters. And next question says, how many seconds does it take the candle to reach the highest point? Would be 3 seconds. Okay, now it wants to know how long it takes to hit the ground. Which part of the graph is that? Where it hits the ground? The x-intercept or the t-intercept, yeah? So I went second trace, number 4 for maximum. I had to go to the left side of it, enter, right side of the maximum, enter, and then enter again. Okay, so we want the x-intercept or the t-intercept. That's when y is 0. So what do? What do? Before you can go second trace. Y equals, y2 is 0. Graph it. And now, which one do you want? The one on the left or the right? The one on the right. Okay, this one. Because does negative time exist? No. So we don't even need that one. Second trace, number 5. You have to make sure to scroll so you're closer to the positive one. Otherwise, it'll automatically find the negative one. And then we push enter 3 times. 1, 2, 3. When does it hit the ground? It's the nearest hundredth. 7.58 seconds. So that's going to be important for our domain. Okay. Oh, I wrote that in the wrong spot. Okay. So let's just jump. I'm going to skip this H and I. And let's just jump to the domain and range. Okay. So what would be the domain of this graph? How far left will it go? In the context of this question. 0 to the domain, which is your time, is between 0 and 5.8. 7.58. Thank you. Yeah. And your range? Between what 2 values is your range? Careful. What's the minimum height the cano is going to be? The minimum height. 0, because he's going to hit the ground eventually, right? You start at 12, then you go up all the way to 21. Obviously, this is not drawn to scale. And then you fall to 0. So between 0 and 21. Okay. Now look at your domain. So when you have a contextualized problem, you really have to think about your domain and range in terms of the context. Okay. If it's just a given graph, you just write your domain and range. Right? Okay. So that's it. So assignment for lesson 6, which we didn't do before, which is good practice, is 1 to 4. 1, 2, 3, and 4. Okay?